Hello and welcome to today's episode on Code with Toyo. So today we are going to be doing something a bit out of the box somehow. So one of the many applications of Python. That's what we are going to be looking at, and Python happens to be excellent when it comes to cryptography. So most of the guys are into cybersecurity. This might be one of the nightmare for a few people. But I just want you to understand that even a layman, you're supposed to understand what cryptography means. It's all about securing or encrypting. Look at it this way: you want to send a message from point A to point B, and you don't want anybody to intercept the message or read the message or see what is in the message. Perfect example: when you're chatting on WhatsApp, you always see this message that says you have an end to end encryption. That means there can't be a man in the middle that will be sniffing on your message or sniffing on your packets, trying to filter your messages for important information and all of that. So cryptography is just all about protecting um, message, protecting information. We have two main categories, or I don't want to call it types, categories of cryptography. So that it is symmetric. That means the same key for encryption and decryption. Perfect scenario is this: you locked up something, and whoever needs to access that thing need to have the same copy of the key for the person to open up that particular package, or you are using asymmetric. Asymmetric is more advanced than symmetric in the sense that it is more mathematically stable. It uses two keys that are linked as one, the public and the private key. So this whole story is much more understandable for people that are into maybe cybersecurity, software development. You see, they say they are using AES, Advanced Encryption Standard, for softwares and all of this. So one of the earliest stage of cryptography is the Caesar cipher. Caesar cipher has a way of encrypting messages by shifting a particular character in three steps. For example, if you send a message in those days using the Julius Caesar cipher, if you have I am okay. Caesar cipher is saying, for this I am okay, you move it three steps ahead of the starting point. For example, I, what is the character of I? JKL. Three step ahead, it will be L, then give it a space. ABC, it will be a C. Then MNO, OPQ, you have your Q, PQR, and in that order. So for Caesar cipher, you just move a character three steps ahead of itself, or a number three steps ahead of itself to give you the encrypted one. So the decryption, of course, when it gets to the destination, they just need to move it three step backward. That is the whole idea about Caesar cipher. But this is just a disclaimer. In current time that we are, Caesar cipher is no longer safe. It's one of the earliest form of cryptography and not no longer in place. But it's always good for you to know the foundation of how it's all started. So you can grow from the foundation to the top and understand why it's no longer safe, the kind of encryptions we're using this day, why symmetric and asymmetric, why asymmetric is a better kind of encryption for public information, especially for websites. You see, there's a public and private key. Whenever you are visiting a site, they say the certificate is secured, especially for transmitting messages over the secure socket layer SSL. Say it's a secure website, this website is not secure, and all of these um ideologies. That's what all these protocols are using. So let's go straight into it and see how we can achieve what a Caesar cipher is using Python. If you have much time, or another video, we'll do another video to create three sessions: a session for sender, a session for receiver, a session for man in the middle or hacker, and see how we can just send messages, and only those with the key can decipher this message. So let's go straight into it using Python. But before then, let's think about it this way. If Caesar cipher works that way, that means we need a collection of the characters we want to use as our steps. Let's just call this, let me call it shift, and let's see what this is giving me. This is already assuming that we have A, B, C, D, E, F, G, H. You can see we have small letter A to Z, capital letter A to Z, then 1 to 9 and 0. So let's assume that is the not a dictionary, a collection of characters that we want to use to make sure that we're able to shift forward and come backward. And we have a message. Let's just say we want to send a message, hello, to somebody. And now we want to encrypt. How do we perform the Caesar cipher encryption? So the next thing we want to say, okay, fine, we want to encrypt. We can go ahead and say for any character you see, character, sorry, I'm trying to rush up this video. For any character you see in this particular message, if the character happens to be in shift, that is this variable that we have here, we want to set an index for it and have it under index. Now we want to create a new index for that character. The new index should be an index moving in three places, and you are ensuring that at the end of the day, it doesn't go beyond the length of the character. That means if this happens to be the message, it will automatically reset back to the first character. So in that way, we keep our length of character the same thing. For those of us that are used to Python or seen Python before, we know what list method is, how list behave, indexing in list, same thing for string. If not, we just want to print out a character. So if you want to test this out and see what it gives us, let's run this and see what we have. So if I run this hello, you can see this is the encrypted version. The encrypted version is telling us that for hello, or yeah, the encrypted version is telling us that for hello, the new word is KHOOR. For some reason, it looks like gibberish, but of course, if you go back to your collection, this is K. Moving three steps ahead, one, two, three, the next character is O. So this is H, moving three step, one, two, the next character is K. Are you following? This is O, moving three step, one, two, three. So you can see encryption is done using Cipher. So let's quickly do a decryption and we can just understand how it works. Trust me, the decryption is an opposite of the encryption. The decryption will happen. Let me just keep this for decryption. Decryption will happen somewhere around here on line 15. That is what will determine what the decryption is. If this message happens to be KHOOR on the receiver side, now how do we want to decrypt? We ensure that the receiver will go three steps backward. As easy as that. Receiver is going three step backward, and if we should run this, you can see it returned hello. What we sent was this, and it returned hello. So the logic for Caesar cipher is three step forward encrypt when you are sending, three step backward decrypt on receiver side. So like I said, it is not so much, it's not even in use in time like this, but you can just see how interesting it is. That means you can create your own little encryption software in Python and add some encryption layer to it, and you can send messages from here to the to your colleagues, and you're able to encrypt, and more it will look like gibberish to somebody else, but then it will be a clear message to them on the other side. So we'll see in another video. We quickly create three files where we can create using the Python socket. We can create a connection and have an attacker into the connection trying to sniff the information, but then We are still going to be using the symmetric, a more advanced symmetric, maybe having a dictionary of characters or using regular expression, and we'll do one that has to do with public key. So this is just a foundational video for all of us to kind of understand how why security is important. So if I'm transmitting this message now over the internet and I am encrypting this message, only the person that understands my pattern of communication will be able to decrypt this message. So again, encryption is very important these days. You are sending your username, your password, you are sending your bank login. When you are logging into your bank account, do you know whenever you try to log into an application, whenever you enter your details, it will go straight, make an API call. The API call is going to pick the password, compare the username, compare the password for identification to know who you are. And as soon as it does that, it returns a token with some key information inside of it that determines your level of authorization. And this is the process that always happens on the background, even in milliseconds as you're working. So you want to always be careful whenever you are entering your information. And that is why when you see a page and the page shows HTTP, you start seeing some warnings that this is not a secure layer of connection. So in the next videos, we are going to do some interesting things with encryption, and then do some more enlightenment. So see you in the next video. Bye for now.